Alright, welcome back. Module 5, Topic 1. We're in probability. And last time we finished all the conditionals, right? If I do this, this happens. If I do that, that's happening. And we were talking about spinners and dice. Now we're into dependent, independent, which can be a little bit more tricky. Okay? Alright, independent events. Let's start with independent events. Okay, two events that are independent in occurrence, they do not affect the probability of the outcome. So, suppose an event N spinning 3 on the left spinner and L on the right spinner, okay, the probability. Now we have all the possible choices, right? So, probability of a 3, probability of an L, or probability of a B. So, 1 out of 4, 1 out of 4. Okay, this is equal to, so the events L and N are independent. Okay, however, suppose that event N is selecting the number 3 and L is selecting the letter B, each from the same set. If event N occurs, a 3 is chosen from the set, probability of choosing the next one of 4, but then it would be less on the next one. Okay, so this is the idea of it doesn't matter. Whatever I do on this dice, whatever I do on this dice, do not affect each other. But if first you picked one, then you pick another, now you've got dependency. Alright, so let's see if we can make sense of this. Study the worked example and then answer each question. Determine whether the event described are independent or dependent. Teacher randomly chooses 2 students from a class, Matt and Mia, to solve the math problem on the board. Describe the event choosing Matt and choosing Mia. Independent. See, it's confusing, isn't it? So first I picked Matt out of the class. Then I got Mia, so it did affect each other, didn't it? Because there was less the second pick. You randomly choose between 1 and 50. Your friend chooses between 51 and 100. Your choice is 6. Your friend is 77. 2 totally different buckets. Independent. Okay. A bowl contains a number of cubes. Withdraw from the cube of the bowl. Your choice is a 3. Your friend is a 5. If it's out of the same bowl, then they are dependent. Alright, so now we got the L and the B, right? Okay, then the number spinning event N and B, we have the same example. Study the worked example. At the local deli, you can have your choice of bread and cheese on every sandwich. You randomly select rye bread and Swiss cheese. They're independent. You're going to pick either one and they don't affect each other. School Ranch offers 5 vegetable wraps. You randomly choose a different one every day. They're independent, not dependent, okay? Because you're doing it on separate days of the week. You randomly choose number ping pong ball. Choose a number of the ping pong ball. Your first choice is an even number ping pong ball. Your second choice is an odd number ping pong ball. They are dependent. Good. Okay, now, the dice problem, okay? 2 dice, you roll them. You can get a 1 and a 1, all the way through 6 and 6, okay? Alright, so now we have all the possible combinations, okay? Now, calculate the probability of rolling an odd on the first cube. Odd, 3 to 6. Okay, probability of rolling an even on the second, 3 to 6. Now, what's the probability of an even and an odd? Okay, so now you have a half and a half together. Okay, this is where you start to multiply. In order to do this, you're going to have only half of the first cube and only half of the second cube. So this is where we have the probability of A and the probability of B. We multiply. So if you're not sure about the math, 1 over 6 and 1 over 6. Okay. Oh, hello. Half and half is a fourth. Hello. 1/2 plus a half. No, David. 1/2 outside plus 1/2. Sorry. Hmm? 1/2 and a half. Oh my gosh. David. 3 over 6. Outside. Parenthesis 3 over 6. That's what I meant to do for a fourth. Sorry. My bad. Okay. So I didn't simplify, and then I typed in 1/2 and 1/2. So my bad on that. Okay. Now, there are 11 students in a math class. Each day the teacher randomly selects one student to show the homework problem on the board. What is the probability that the same student will be chosen 3 days in a row? Well, the probability of choosing me is 1 out of 11. The probability of choosing me is 1 out of 11. The probability of choosing me is 1 out of 11. But now it's 1 out of 11 each time. Okay? So now 1 out of the 11, 1 out of the 11, and 1 of the 11. It's not very likely you get the same person every time. Wow. Huge number. Okay? So now we're going to start to build our cheat sheet. So in class, we have the probability of, okay, A and B. Probability. So independent events. Okay? Alright, so now probability of the heads. The shell game consists of 3 opaque cups representing shells upside down on the table, and hiding the ball under the cups. A player who has not seen where the ball is hidden has to choose from one of the cups. If the ball is hidden under it, the player wins. What's the probability that the player will win 5 times in a row? Well, the probability of hitting it is 1 of the 3, right? Five times in a row, 1 of 3, 5 times. Okay, so each event, right? 1 of 3, but then you have it 5 times in a row. Spin the spinner routine. What is the probability of both spinners land on a 1? Well, this is 1 of 6, 1 of 4. 1 of 6 times 1 of 4. Evan has 6 quarters, 4 dimes, 3 nickels, 2 pennies, and a penny. He randomly removes coins from his pocket and replaces each coin each time. You got to put the coin back each time. What is the probability of choosing a quarter, then a nickel, then a dime? So let's go to 6 quarters, 4 dimes, 15, 21 coins. Evan has 7, 15. There's 21 coins. Quarter, 6 of 21 times a nickel, 3 of 21 times a dime, 4 of 21. Cool. Okay, probability of this and the probability of that. Probability of this and the probability of that. Okay. Alright, probability of choosing a number of cards, 2 of the 4 or 1 of the 2. Alright, so now the probability. Okay, consider the cards in the example. Are the events? Choose a letter of a card. What are the independent events? Probability of a card. Card 2. 2 of 4. Probability of a square card, 2 of 4. Probability of a letter and a square. These are independent, so we're going to have 1/2 times 1/2. Meteorologist said 80% chance of rain, 50% chance of damaging winds. She also says there's 20% of rain and damaging winds. Are the events of rain, damaging wind independent? Chance of rain, 0.8. Damaging winds, 0.5. 0.8 times 0.5. She also says there is a 20% of rain and damaging winds. Yep, this is a tricky one, wasn't it? All right, well, we completed another workspace. Let's see where we're headed here before we go on. Yep, we're going to go to probabilities.